Okay, so let's talk real quick about function transformations. Let's say that this function here in red is my f of x function, and I want to move the function to the left 2 units. This would be the notation that I use, f of x plus 2, right? Where the plus 2 in this situation indicates that I'm going to move to the left by 2 units. So how could I do that? I could do that by plotting each of my points. So I have a point here. I'm going to move that point to the left 2 units. Here's another point. I'm going to move that point to the left 2 units. And I can do that for each of my points. And once I have enough of my points plotted, then I can come over and, if I wish, use a straight edge and be able to continue my graph. Right, so I would have something like this, and I could say, okay, well, now I have the graph of f of x and the graph of f of x plus 2, which has been moved to the left 2 units. Okay, now what would some other transformations look like? Well, let's say that we had another function, and this function was g of x. And I wanted to move this function. I wanted to move this function downwards by 3 units, right? I could take every point and go 1, 2, 3 units down at every point that I have, 1, 2, 3 units down, and do that for each one of my points. And once I've done that for each one of my points, right, I could come over and use my straight edge and complete my graph, right, and looking to try to complete it as neatly as possible. Okay, and this would be my graph moved down by 3 units. But what would be the notation for that? The notation for that would be g of x minus 3, right? That I've taken my entire function g of x and moved it down by 3 units, right? Of course, others may wish to write the down 3 units first, and that's fine. And so I could write it as -3 plus g of x, right? What if I wanted to move this function upwards, right? Then if I wanted to move it upwards, instead of saying the function minus 3, it would be the function plus 3, right? And notice the distinction about moving down, right, or moving up as compared to moving to the left, right? To move to the left, I would have to f of x plus 2. And if I wanted to move to the right, that would be f of x minus 2 would be to move right 2 units, right? So if I wanted to take this function and move it to the right, this is what it would look like. And if I wanted to take my function and move it upwards, right, this is what I would have for moving upwards, okay? Now, there are some more transformations that are going to be important for you to be familiar with. And one of those other transformations for you to be familiar with is one where we are going to talk about reflecting, right? One where we're going to talk about reflecting in the x-axis, right? And if we want to reflect in the x-axis, right, what I can do is I can say, hey, here's a point 1 unit above the x-axis. Let me mirror that point 1 unit below. Here's a point 2 units above. Let me mirror that point 2 units below, right? Here's a point 5 units above, so I could come back down and mirror that point 5 units below. And similarly, I can do that for other of the points. And if you continue that mirroring, we'll have this mirror image where we can see that we have reflected across this x-axis. As you're plotting the points, it's okay if you make a little mistake. You could come through, right, and just do a light cross out or leave it alone. We can see what our reflection is like. But what would be the notation that we use? What would be the notation to talk about this reflection? And that notation that we would have, if our function up here was h of x, right, then the reflection would be negative h of x, right? That I'm going to take every output value for my function, and make those outputs negative, right? So if I was 3 units above my x-axis, right, opposite that is going to put me 3 units below, right? But I have h of x, and then I have negative h of x. That's going to give me a reflection in the x-axis. It is important to recall these transformations. And let's look at one more transformation. So let's say that we had this other function j of x, and we wanted to, right, we wanted to take this function and we wanted to reflect in the y-axis, right? Well, if we're going to reflect this function in the y-axis, what we need to do is find points, right? And if a point's on the y-axis, it's going to stay on the y-axis, but find points and find their mirror image across the y-axis, right? So this point that's 1 unit to the right, we could plot the point as 1 unit to the left. Over here, 2 units to the right, I could be 2 units to the left, right? Down here, 1 unit to the left, I could go 1 unit to the right. And I can continue to plot some of those important points and see what I get. So as I plot those points, I get this reflection in the y-axis, okay? And this reflection in the y-axis is going to have a notation. And that notation is going to be that I'm going to put a negative in front of the x inside of my function. So whatever the input was, now I want to reflect it across the y-axis. So I'm going to say negative my input. And that's going to give me that reflection in the y-axis. Okay? So these are some basic transformations that are very important to recall. We'll continue with some other information in videos to come.